All right. So I'm going to try to get going quick. We're going to have time to go over stuff. It's going to be tough. What was due yesterday? Module 8 reading, Module 7 quiz, and then that second pack back. So I don't know if I'll get it up this afternoon. If not this afternoon, definitely tomorrow morning, you'll see the third pack back assignment pop up. I had it ready to go, and then I saw some things happen in the news that were really closely related to it. So I want to present some more up-to-date articles than the one I was using. Although it's the same thing, but I just think to make it more relevant, I want to go out and find a couple more resources to kind of give you. So you'll see that pop up. It'll be due before we leave for spring break. So we've got this week, we've got next week, and then spring break. So the end of the day, next Friday. That way you don't have to worry about it over spring break. I don't have to look at my email, right? We'll kind of have that due date for that third pack back be the end of the day next Friday. As we get closer to the exam, I'll kind of talk about next week. I'll get a practice exam up there. You know, the exam's the first week after spring break, so it's going to be kind of weird. We'll talk more about that next week, but just kind of foreshadowing where we're going. Other than that, the second quiz, I did want to make you guys aware of. After I get back to my office, I'm going to update it. Question 2, I changed it based off what we talked about in class before I posted it, and I updated everything except for one word, which ultimately made it so there was technically no correct answer. Now, one of the answers was closer to being correct than any of the other. It was kind of half correct. So I probably could grade it and still just accept that. But I feel like that's not completely fair. So my mistake is your gain. I'm going to give everybody credit for question 2, right? So it was that it creates deadweight loss, but it's not from the underproduction. It's deadweight loss coming from the overproduction, right? So that kind of caused any confusion. I want to be fair to you guys, going to give everybody credit for that one. But none of the other answers were even remotely correct. At least that one, like it does cause deadweight loss. It's just that the reasoning wasn't quite right. So I'll update that one so that when you're studying for the exam, you'll have kind of what the correct answer should have been. And I'll give everybody credit for that question number 2 once I get back to my office. Okay. Other than that, any questions for me before we kind of jump into material here, kind of hit the ground running today? Okay. We all showed up despite how nice it is out. It's not, maybe if it's like a 1 o'clock class, I'd have absolutely nobody in here today. So we're going to switch gears quite a bit, right? So modules 5, 6, we combine very closely related to 7. A lot of surplus, a lot of, supply and demand. We're going to specifically focus on consumers this week. And then next week, we're going to specifically focus on producers. Also, I've been up since 3:30. So if I say something that doesn't make sense, please stop me. I think I'm still firing on all cylinders, but I'm noticing I'm talking fast and I'm already like, did I just say what I think I meant to say? So what we're going to talk about is consumers this week. We're going to start out thinking about a budget. So if you're going out and you're going to buy something, just one good, right? If you've got a certain amount of money in your pocket, you face these prices, I don't know, you go to Kohl's or TJ Maxx or something. If you're just buying one and you only want to buy one product, how much can you buy of it? You have $100 in your pocket and something costs $20. How many can you buy? What did you do in your head there? You took the total amount of income that you had and you did what? Divided by the price. Right? So ultimately, that's what we're going to be doing in a slightly different context with this budget line, right? So instead of one good, when you go to the store to buy things, everything has a different price, and you can buy more than just one type of good. So ultimately, how much can you afford to buy? Well, however much money or income you have, we'll call that M. That's kind of the notation we use in economics. That's why we did it in income elasticity. We were kind of using M there. It's the total amount of good X you buy times the price of good X. That's how much I can afford to buy. Plus, however many units of good Y I'm buying times the price of good Y. When I add those up, if I'm spending all of my income, I can afford that combination of good X and good Y. Now, if I'm only thinking about buying one good, that equation becomes easier, right? Because then I only have the price of good X times the quantity of good X. So this will be our kind of starting out our budget, we call our budget constraint, right? Or our budget line, a budget equation. Right? So ultimately what it's going to end up at the end of the week playing a role is that we're going to try to maximize something that we'll talk about later today, which is utility, but we have to maximize it facing a budget constraint. we've only got a certain amount of income in our pockets, and things are not free, right? Things have prices, okay? So we're limited in how much we can afford to buy. Okay? So let's kind of think of an example here where I've got what? Prices are 2 and 5, and my income is 40. So if I'm only buying good X, how many total units could I buy? I would just take my income and divide it by price of good X, so I can afford to buy what? I'm looking at sort of what 5 times 40, so 20. If I'm only buying good Y, how many can I afford to buy? I would take my income divided by the price of good Y, 40 over 5, I could buy 8. So those are like my two extreme points if I'm only buying one of each good. So I'll kind of maybe, this gets a little bit tricky, but let's say I wanted to buy, I'm currently only buying good Y. Right? I'm buying 8 of them. Let's say I want to buy 1 unit of good X. Actually, no, I'll do the different one. Let's say I want to buy 5 units of good X. Well, if I was spending all of my money before on good Y, if I want to buy X, what am I going to have to do? Buy less of good Y. Right? In fact, if I want to buy 5 more of good X, what would the total cost to me be? $10. So how many of units of good Y am I going to have to give up? 2. Our budget constraint, we're end up going to have a visual that goes along with it. It tells us what that trade-off is, that as I want to buy more of one good, I'm going to have to give up more of what I'm buying of the other good. And what's going to determine how much I have to give up? Well, think about it this way. What if I wanted to get those same 5 units of good X, but they only cost me $1? Well, now how much of good Y would I have to give up? Just 1, right? So what matters in terms of how much I have to give up? The relative prices, right? So we'll kind of build this out a little bit more, but essentially our budget constraint, and here I could plug in income, but just in general, no matter what amount of income I have, it's going to be the prices of these 2 goods multiplied by the quantity I'm buying. This is going to tell me the different combinations of those 2 goods I can afford for any amount of income. Okay? So we'll come back here. I'm going to draw some stuff for us. Okay. So let's say, and I'm going to do this everything like in general terms. We could just plug in different values to it, but I think this will help kind of set up some of the things that we're going to talk about. So let's say I've got 2 goods, X and Y. I can call it any 2 goods we're thinking about. Right? We said if I'm only buying, right, here was my budget constraint. If I'm buying these 2 goods, how many total can I afford to buy? The price of each good times how many I'm buying. Now we said if I'm only buying good X, what would the quantity of Y actually be here? 0. So how can I find how much of good X I can buy? Well, if I want to know the total quantity of good X I could buy, I have to kind of rearrange this equation a little bit. So I would be left with this, divide both sides by the price of good X, and that's why the total amount of good X, if I'm only buying good X, that intercept would be the amount of income I have over the price of that good. Now you can kind of think about it intuitively, but mathematically we can prove that as well. Same kind of thing for good Y. What do you think is going to end up happening if I solve for how much of good Y I can afford? It's not going to be income over the price of good X. It's going to be what? Income over price of good Y, right? That's how many of good Y I can afford. So we can find these 2 intercept points, I think, relatively intuitively. Now, as I want to go from this point where I'm only buying good Y, if I want to buy more of good X, we said I'm going to have to do what? Give up a little bit of good Y, or I'm facing kind of this downward slope. What does this look kind of similar to? First midterm, PPC. Now, PPC, we were talking about production. Here, we're talking about consumption. So I can buy, it was instead of using all the resources I had to build things or make things, I'm using all the resources I have to buy things. Okay. So there's this trade-off between the 2. What's the slope of this equation going to be? So we could actually find it from this. I'll show you 2 different ways to think about what the slope is here. And it's a little bit counterintuitive. So going to give myself some space to do math. I'm not going to make you reproduce this math. I'm just giving it to you for support. Okay. So how would I find the slope of a line? The change in y over a change in x. What are my x and y's here? This is a change in the quantity of good y over the change in the quantity of good x. If I'm moving between these 2 points, what is the change in y? I'm going from m over the price of good y to 0. So 0 minus m over the price of good y. Moving between these 2 points, what's the change in x? It's going from 0 to m over the price of good x. Well, what is this? This is m over the price of good y over m over the price of good x. Same thing in the numerator. Cancels. If I have 1 over the price of good y divided by the 1 over the price of good x. Once again, I'm not going to make you reproduce this math, but 1 over something divided by 1 over something is the same as kind of flipping those, right? So I've got the price of good x over the price of good y. And technically, what did I forget this whole way down? Sorry. There's technically a negative sign in front of all that, right? 0 minus that. Okay. So the slope of my budget constraint will always be the price of good x over the price of good y. So it's the relative price of good x compared to good y. This kind of looks counterintuitive because, like, how do you calculate the slope? Well, it's the change in y over x, but what's on our graph? Our y and our x are the quantities. So if we want to find kind of the slope in terms of prices, it's going to be the reciprocal of that. Okay. So a little bit counterintuitive, but the math kind of proves this to us. Okay. Any questions on that before we keep moving? Okay. I'll show you one other way you could get to that slope, right? Maybe some of you find this really boring. Once again, I'm not going to make you necessarily reproduce this. Oh, sorry. I jumped the gun. I'm talking and writing. So here was my budget constraint, right? We said when I'm spending all of my income, it's the total amount of money I'm spending on good X, price times quantity I'm buying, plus the total amount I'm spending on good Y, price of Y times the number I'm buying. If I start to do a little bit of math, so I subtract. So why am I doing this? Sorry. Ultimately, if I want Y as a function of X here, what's on my Y-axis? The quantity of Y, and I want to solve for it as a function of the quantity of X, right? That's how I, math, that's a line. Y is equal to some function of X. So I'm going to try to solve for that quantity of Y. So I'm going to subtract this from both sides. I'm left with what here? This cancels. Divide both sides by the price of good Y. This cancels. Just going to move this over. It's equal to m over the price of good Y minus the price of good X over the price of good Y times the quantity of good X. What does this look really similar to? Y is equal to mx plus b. Here's my intercept. Sure enough, that's what we said before. Here's my slope. Using the kind of rise over run, we get the exact same slope that we had over here. Okay. So kind of just two different ways that support that this budget constraint, the slope will always be that relative price of good X to the price of good Y. Now, once again, I'm not going to make you run through this math every single time. We'll have some values associated with this, and we'll kind of see how this plays out. But I don't know, I sometimes, just telling you something, I think it's useful, especially those of you who are a little bit more math-minded, to kind of see where that comes from. Okay. Kind of unveiling the black box, so to speak. Any questions over anything here before we keep moving? Is this kind of making sense here? So this line, right, came from my budget equation, which was assuming I was spending all of my income. So when we're looking at our budget constraint, and I'll kind of simplify it here just so we don't have as much stuff going on here. So any point on this line is a combination of good X and good Y that I'm spending all of my money. So I can afford it, but I'm using all of my resources. This is going to be pretty similar to what with the PBC? For the PBC, we said points on the line were production efficient. Here, we would probably say they are consumption efficient. Now, we usually don't use that terminology, but just to connect with things we've already done, I think that might help. So these are points we can afford, and we're using all of our resources. What would any point down here represent? Inefficient points. So that means in terms of consumption, yes, I'm buying a combination of these two goods, but I could buy more. I've got money sitting around left in my pocket. Now, you might be like, well, yeah, but people do that. They want to save money. Yeah, but how would you model that? You should never just truly have money laying around, because what could you be earning on that money? So instead of just letting it sit in your pocket, what good could you buy? A CD, stock. Well, stock maybe is a bad because you're not guaranteed to make money, right? Anything where you're kind of guaranteed to make a return. So people in practice do this. We use all of our income, even if some of the goods that we're thinking about them buying are like financial goods, right? I mean, not everyone does that. They should, if they're doing the optimal thing, do that. What would any point up here represent? These are going to be points that unattainable in terms of a consumer. We would say these are unaffordable, right? So very similar to that production possibilities curve. Okay. In fact, it gets almost a little bit easier because with the production possibilities curve, we didn't really have like prices associated with things, or the prices were a little bit harder to think about. A little bit easier with consumers. So we've really, I think I've said all of these things already, but right, we talked about these different ranges in terms of affordability, right? Thinking about unattainable being now unaffordable, right? Points below, this is not, we're not using all our resources. The slope we kind of already talked about is always negative. And just kind of adding an assumption here, I'm always assuming these models we're looking at, that when we're talking about the price of a good, this is like you're paying the same price if you bought 1, 2, 3, 4 per year. Obviously, if we go like the next level of economics, we start to talk about things like quantity discounting and things like that. But for now, you're thinking, if I go to buy a gallon of gas, what's the first gallon cost? I don't know, $2.90 or something this morning. What's the second gallon cost? $2.09, right? It's the same price, right? So we're thinking about goods that kind of have that same sticker price for every unit that I'm buying. Okay. So let's kind of just put some numbers to it. Think about a stupid example. I shouldn't do this negative self-talk, but an example that's kind of good, right? So let's say I'm trying to reinvent my image this summer, and I'm only going to buy PBR, which, if you're not aware, is a terribly cheap and most people think disgusting beer, but hipsters drink it, and I'm just buying flannel shirts, right? So flannel shirts cost me $20, PBR costs me $5. I've got my prices. Okay. If I have $200 to spend, that's going to be my income. So let's start to think about my budget constraint here. If I put flannel shirts on my x-axis and PBR on my y-axis, what would my budget constraint be? Well, I've got my prices, right? So we've got this on the slides, but we can kind of start to think about this. We've got the general kind of version here. If I've got flannel shirts on my x-axis, PBR on my y-axis, right? I know my budget constraint is going to look something like this. We said income was $200, price of PBR was $5, price of flannel shirt was $20. If I'm only buying flannel shirts, how many total can I afford to buy? Well, if I've got $200, each one costs $20, 10, right? What if I'm only buying cans of PBR? I've got $200, price is $5, so 40. Okay. So just plugging in my income and those prices to kind of figure out where those intercept values are. Now, notice here, if I had these quantities, what is the slope of my budget constraint? What's the change between these 2 points in Y? I'm going from 40 to 0, so negative 40. Right, if I'm just doing kind of my change in the quantity of Y over the change in the quantity of X, what's the change in my X good? 10. So I should have this slope of -4. How could I have also found this? We said that slope is equal to the price of my X good over the price of my Y good. What are my prices here? Oh, sorry. I'm looking at this backwards. The price of a flannel shirt is 20. Price of PBR is 5. Sure enough, I get the same slope. So whether or not I use the relative price or whether or not I use those quantities, I can find that same value from the slope of my budget equation. And for different problems or different things, we'll see why we might need to do one relative to the other. Okay. Any questions on this? It shouldn't be too bad, I don't think yet, but if I just want to make sure, we're getting a good base before we start to complicate things. Okay with this? Okay, so we'll come back to this here in a second. We just set all of this up. Oh. So I kind of showed you where they would be. Well, let's say I had 3 points. So I got 3 different consumption bundles. We already talked about where those intersect values are. Are these going to be on my curve, above, or below? What's a really quick way I can check to see where they're at? On, above, or below my curve? So if I have the combination of the 2 goods I'm buying, what's the total amount of money I'm spending? So if I'm buying 2 flannel shirts, what's the total amount of money I'm spending on flannel shirts? 2 times 20 or 40. 25 PBRs. Total amount I'm spending on them would be 5 times 25, so 125. So what would those add up to? 165. So am I doing mathematics right there? 40, yeah, 165. So am I spending all of my money? How much money did I have? 200. So no. So where would that point be relative to my budget line? Or below. Yep. What about this point? How much total money am I spending? 8 times 20 is 160. Plus 8 times 5 would be 40. That would be equal to exactly my income. That must be a point that is on my curve. So it would be kind of like consumption efficient. What about this point? I'm going to guess it's above since it's what we haven't done. But 5 times 20 is 100. Plus 30 times 5 is what? 150. So 250. I'm spending more income than I have. So that point of C is going to be somewhere above my curve. So this is one way you got a quick, easy kind of check to see, are these consumption bundles affordable? Are they unaffordable? Or can I afford them, but I'm not spending all of my income? Any questions on this before we keep moving here? Once again, this should kind of look similar to that PPC stuff. All right, we're going to throw in some additional wrinkles now that don't look the same. But at least this, starting out, we have something to kind of reference there. Okay. All right. Decrease, or sorry, not price. Let's do an income decrease. Okay. So if I have less income, what's going to happen here? If the prices stay the same, but I have less income, what's going to happen to my budget line? Yeah, if I'm only buying good X, I can afford to buy less. If I'm only buying good Y, I can afford to buy less. Right? So when I have less money, it doesn't matter which good I'm buying, I can buy less of it. I get these parallel shifts. Why? If prices haven't changed, what should the price of my budget constraint be after my income goes down? Still the relative prices. Right? And when we were kind of doing the math, the reason why is, remember, like here, like income canceled out. That's kind of where that comes from. Doesn't matter if I have less income, it's going to impact both goods equally. Right? So here I end up with kind of this decrease in my budget line if I saw income decreases. Okay. I'm going to draw this out again real quick, because I didn't leave myself enough room. So let's say we just had that. That was an income decrease, right? And if you left yourself room and you don't have this here, you can put us all in the same graph. I'm just kind of cleaning it up a little. So what's true about all the points in this range? They used to be not only affordable, I wasn't even using all of my income. What's true about those points now? I can't afford them. I have less money. Can't afford to buy the same. What if I had income increases? Well, now if I'm buying good Y, I can buy more of it. Good X, I can buy more. Income increases do what? Cause points that I used to be able to not afford. In fact, some of those points now, I'm not even spending all of my income. I can get to points out here that were definitely unaffordable before. Okay. So that I think is probably one of the easier change, the income changes. It's just going to kind of shift that budget constraint. Why? Because the relative price determines my slope. So the slope will always be the same. It's only going to be parallel shifts when I have income changes. Does that make sense? Any questions on that? The next one's trickier. Also, I'm taking this class. I'm not supposed to say things like this. I'm really trying to cut it out of my language. I'm not supposed to say harder, easier, trickier. It's a teaching pedagogical thing. But like, this is I think easier. This is a concept that might cause you less difficulty than the next concept we move to. Okay. So, and I'm not like making fun of that. I think there's value in me not speaking that way, but old habits die hard. So let's say instead, I've got this original budget constraint, and I think we were at what, 10 and 40? Let's say that the price of flannel shirts goes down. Okay. So if I'm buying flannel shirts and the price is lower, I have the same amount of income. How many can I buy? More. What if I'm buying PBR? Its price is the same. I can buy the same amount. So notice what's happening to my budget constraint. It's not shifting parallelly out. It's just getting kind of kicked out there. Now, one thing that's going to be true here is there are now points that used to be what? Unaffordable that I now can afford to buy, right? Very similar. So that price decrease. So this is if the price of flannel shirts decreased. What was that very similar to in terms of allowing me to afford different or higher bundles now? It was just like I had an income increase. When prices are lower, the same $100 in my pocket can buy more things. So what's going to be true about the slope of my budget constraint? Remember, the slope of my budget constraint was the price of X over the price of Y. So here that was the price of flannel shirts over the price of PBR. If prices go down, what's happening to my slope? Well, if the numerator is lower, my fraction is also lower, right? So notice what's happening to my slope. It's getting flatter, which a completely flat slope has a slope of 0. So we're getting a slope that's kind of approaching 0 there. Okay. Any questions on this idea? So this other one might be a little bit more difficult, right? So we're going to use this same idea where here was the slope of our budget constraint. But now let's say the price of PBR goes up. Okay. The price of PBR goes up. If I'm only buying flannel shirts, what's happened to the number I can buy? Doesn't change. If I'm buying only PBR and the prices are higher, what's happened to the total amount I can buy? It's got to be lower, right? Got the same money in my pocket. Prices are higher. I go out to the bars and they're charging twice as much. I can only afford to buy twice, half as many drinks, right? So not that any of you should be out at the bars yet. So what's going to happen? I get this kind of shift down in my budget constraint. What's true about the slope? Well, it's getting flatter here. Why? You might be like, well, wait, that doesn't make sense. The change in the price of the other good made it flatter. Why is this one making it? Well, because the price of PBR, that's in my denominator. So if this goes up, what's happening to my fraction? Larger denominator, that fraction, which represents my slope, is going down. Okay? So an increase in the price of my Y good here is actually going to make that slope a little bit flatter. Now notice here, when prices went up, what's true about all these points? These used to be, so based off of the original line, I used to be able to afford them and have extra money. After the price went up of this good, those points are now unaffordable, right? So notice when I have price increases, this is why like people hate inflation. When prices go up, what impact is it very similar to? It makes some things I used to be able to afford no longer possible. It's the same as if I had less income. So even if I have the same amount of money in my pocket, when prices go up, that money has less real value, right? I can't afford to buy certain consumption bundles that I was able to before after that price change. Now, why do we like prices going down? Well, what's that very similar to? Even if I have the same amount of money in my pocket, but prices are lower, I can buy more things, right? So price decreases are just like I had income increases in terms of like making things I couldn't afford, I now can. Now, they're not the same in that it's not a parallel shift. It's just going to kind of kick out one of our intercepts, okay? Any questions on anything here before we keep moving? Is this hopefully making some sense? Okay. All right, where are we at in time? All right, we're good. So what do I want to make sure we got at least 30 minutes? So we got it here. Okay, perfect. All right. So we can put some actual numbers to this. So let's say instead my income went up to $300. Well, how would I figure out what my new budget constraint is? Well, I would just take that income and divide it by the price of each good. So if the price is still 20 here, it would be 300 over 20, which would give me that intercept of 15. What if I'm only buying my Y good? New income is 300. The price was 5. Divide that, I'll end up with 60. Oops. And then if I plug in my relative prices, once again, I notice, oh yeah, the slope hasn't changed at all. The prices haven't changed. So the slope of my budget constraint when I have an income change, slope should remain the same. It's just going to shift it in or out. Okay. Here we had an income increase, so it shifted it out. I did everything kind of in general terms here. Here's like specific to the example we were using, just thinking about an income increase with some actual values. Any questions on that? So the next one might be a little different. So what if the price of flannel shirts falls? All right, so we have a price decrease. Well, what good is the price decrease in? I think the example I did for you was a decrease in the price of good X. Or maybe not. No, I did Y. I did it the opposite way. So if I have if I have lower prices and I'm only buying flannel shirts, I can now afford to buy more, right? So if I take that same $200, I can now afford to buy instead of 10, 20, right? 200 over the new price of 10. What's that going to do to the slope? Well, we said it won't be 40 over 10 anymore. It's going to be 40 over kind of my new value, so 40 over 20. Or instead of using the quantities, I could also use my relative prices. My new price of a flannel shirt or my x-axis good is 10. Price of that y-axis good didn't change. That PBR was 5. So notice whether or not I use my new quantities or I use my new prices, I find that slope has went down. Right, or decreased, gotten closer to 0 in magnitude. So you can kind of prove this to yourself, not just using kind of the general kind of, notation, but actual numerical values. Okay. Any questions? How I came up with anything here? What else do I want to do here? So what if the price of flannel shirts went up? Right? What's that going to do? So it's not going to cause it to shift out like this. If flannel shirts, the x-axis good, are now more expensive, what's going to change here? My y-axis change. I'm buying PBR, and the price of flannel shirts change. No. Right? Yeah, it's going to change my x-intercept. I'm going to be able to buy less. So what's going to be happening to my slope? It's going to be increasing, which means my slope should be a larger value in terms of magnitude. How could I find the new value of my slope? Well, let's say the price of shirts went up to 40. What would my new slope be? So remember, the slope is the price of your x-axis good. So that's now 40 over the price of your y-axis good, which was 5. So the slope would now be what? -8, which is steeper than -4. So when you think about how these price changes in either direction are going to influence kind of the slope of that budget constraint. Okay. Any questions or anything there before we keep moving here? And so I turn these into some questions. So don't worry about this. This is just kind of something that we'll talk about here in a second. I'm going to have this set to be, 10 and 2. Give you guys 10 minutes to kind of work on this. So I'm going to give you a preface of this. I just put this together, and the answers, if you submit it, might not be the correct ones, right? So don't worry about that, right? Just worry about trying to identify the correct answer. After you submit, the feedback you get, it didn't alter anything. I just wanted to make sure I had these questions written to be able to use for class, because I think they're worthwhile for us to kind of go over. So I'll give you guys the next 10 minutes, kind of work on those 3 questions, talk to the people around you. It's going to be very similar to some of the concepts we were just talking about, calculating the slope, thinking about the intercepts, thinking about what shifts in that budget constraint would look like, and then we'll kind of come together after you submit it and we'll talk about it. Okay? We'll give you guys, like I said, I have it set to be 10 minutes from now, so maybe like the next 8 minutes or so to kind of work on this. Okay? I mean, I'll leave it open the full 10 minutes, but. Or maybe some of these things might be helpful. Like I said, talk to the people around you. You don't have to be perfectly silent during all this. The person next to you might understand something you don't, vice versa. All right. So I can see people working, talking, tend to be a little bit kinder. So as long as you get this submitted in time, I'll give you all credit for no matter what your answer are. So make sure you're getting this submitted. We're going to walk through them right now, but just because we might not get through all of them, you don't have to have the correct answer to kind of get the full points for the day. So just submit what you've got right now. I'll kind of go in after class, give you full credit for every question. That way we're not running into issues where you're like, well, I tried to submit it right at 10:21, get it submitted now ahead of time. Is anyone having any Wi-Fi issues, not able to get this connected or connected, submitted? Okay. As long as you get it submitted before what? 10:22, we're good. No one told me they have problems. So if I get an email, in the last section, I did the same thing and I still got an email that the person had issues, even though I did this whole preamble, which probably lets me know that they weren't in class. So don't lie to me. Doesn't make me happy, right? So everyone kind of no submission issues here. Now's the time to let me know. Perfect. All right. So let's take a look at these. Okay. So here I've got one where I've got tea and coffee. So I've got a budget constraint, and I know I have $200, and I'm asking you, what's the price of the y-axis good tea? So how could I figure out what the price of that y-axis good is? So what's something that might be helpful? If I know the intercept, right, when I'm only buying tea, so you can kind of think about this a couple different ways. So we've got this example where I've got coffee, tea, right? If I'm only buying tea, I was buying 50, right? If my income is 200, well, I could think of it two different ways. One, what's my budget constraint? Well, it's the price of the X good times quantity of X I'm buying, price of my Y good times the quantity of Y. Well, our X good here, we're buying 0. This is not Y, this is T, right? So if I have $200, The total amount I can afford to buy is 50. What does the price have to be? Do a little bit of algebra. The price of T has to be what? $4 here. Right? Now, I could have also kind of looked back at, oh, how do I find that intercept in general form? Oh, yeah, it's always just M over the price of my Y good is equal to the quantity of that Y good I can afford. So once again, I could plug in my 200, plug in my 50, just algebra, whoops, working in a different direction, I'd still come up with that same price of 4. Okay. Any questions on that before we keep moving here? Okay with that? Okay. Let me think if there's anything else I want to say here. Any questions in this before we go to the next? Yes? No? We're good? So what if I have a very similar example, coffee and tea? I think I changed the graph so the numbers look a little bit different, but I kept the goods on the same axis, right? So we've got what? 40, and I think it was is 100 or what did I do? Yeah, 40 and 100. And then I said, assume that all you have is the price of tea is $2. So I don't have income here. Now, even though I don't have income, how could I figure out what income actually was? Let's say I asked you that question instead. Well, what did we just do? If I know the total amount of tea I can buy is 40, when the price is 2, what must my total income be? Yeah. Income is equal to, if I'm only buying good Y, right? Price times quantity. I know the price, I know the quantity. Must be I had $80. Now, it's not what I asked you for. I asked you for the price of a cup of coffee. So here, what's the slope if I use quantities of my budget constraint? It's just the change in Y over the change in X. So the change in Y goes from 40 to 0. So negative 40. Change in X, I'm going from 0 to 100. So negative 0.4. What do I also know the slope is equal to? Negative the price of my X good over the price of my Y good. So here I know that the slope should be equal to the price of a cup of coffee over the price of whatever, a cup of tea. This is $2 was given to us. A little bit of algebra, multiply both sides by 2 here. And I end up with a price for a cup of coffee would be what? 2 times, here it's negative, so the negatives cancel. 2 times 0.4 or $0.8. Okay. Any questions on that? What did I say before the quiz started? I said, don't worry about what the answer that it tells you, right? Yeah, I'll get on after the fact. I just wanted to kind of use these questions. I had to have a correct answer set, right? And so I didn't worry about it. I had an idea that if you guys were working, I might kind of give you guys full credit just for answering. So I didn't kind of update it. But yeah, the answer should be 0.8. I'll get it changed though. So if you want to review it, I'll get it changed when I get back to my office. So you'll kind of have that correct answer when you're reviewing it. Any questions how we got to that value? Yeah. So you use your quantities to first find your slope. You then know your slope is the relative prices. So if I know the slope and I know one of those prices, it's just a little bit of algebra. I guess I didn't do the algebra, right? I would multiply both sides by -2, and that's kind of where I came up with that equation. Yep. Any other questions on this one before we keep moving here? Okay. So on the final one, we kind of already talked through a lot of these. I'm going to talk through this as opposed to drawing this, since I have the nice visual here. So which of the following basically is true? So let's just talk through all of them, what they would all represent. So what would B represent? So if the original budget constraint is this black line, B would represent the price of what good changed. My X good. Not only did it change, I can say that the price must have went down, because if now I use all of my income, I can afford to buy more. What would C represent? If the price of what good changed? Y. What must happen to that price of good Y? The intercept is higher, I'm buying more, so the only way I can afford to buy more with the same amount of income is if the prices went down. So C and D both represent price decreases here. Now, what could slope A represent? So we don't have any price increases. What would price increases have to do? It would have to put us at a point that is below our budget constraint. So A most likely would represent what? An increase in income. Why? Because not only did you see the intercepts change, but the slope of your budget constraint, or that relative price of the two goods, has remained unchanged. Okay. Now I'll give you an example of how A could also represent something else. So the option that I gave you here was that what if we had simultaneous increases in the price of X and Y? Well, if I had simultaneous increases, what would that do? If the price of X goes up, I can now afford to buy less of it. If the price of Y at the same time went up, I can afford to buy less of it. I could actually kind of see like this parallel shift. Now, I won't kind of do anything in terms of like making it disproportionate. I would expect you to know that you could get the same thing as an income change from simultaneous price changes. So let's say before, like the black line, the prices were 10 and 5. Now, the price of my Y good was 10, price of X was 5. What would the slope of that line be? So remember, the price of Y is 10, the price of X is 5. The slope is the price of X over the price of good Y. So I would have what? -1/2. What if the price of Y went up to 20 and the price of X at the same time went up? Sorry, I'll do it. I have to increase here. So let's say the price of Y went down to 5 and the price of X went down to $2.50. So if I'm buying either good, I can now afford to buy more. What's the new slope of my budget line? So the price of my Y good went from 10 to 5. Price of my X good went from 5 to $2.50. What's the new relative price? 250 over 5, which would still be -1/2. So if you have simultaneous price changes, you can get what looks like an increase in income, right? We can kind of see this shift out to budget constraint A if we had proportional changes. So this is where if I ever ask you a question kind of related to this, it will be simultaneous changes in the prices that were proportional. So it won't impact the slope of that budget. You can imagine in the real world what happens. Well, maybe the price of one went from 10 to $2 and the other one went from the price of 5 to 4. So not only did I see a shift, but I also saw a change in the slope. It gets more complicated. I won't do that to you, right? I'll only ever give you kind of one price change and then have you calculate the slope. Or I would maybe give you this instruction of what if you saw simultaneous price decreases that were proportional. So this word of proportional means, you know, the slope, those relative prices aren't changing. But when you have simultaneous price decreases, it would look very similar to an income increase. This is why we like prices to be lower. Because if prices are lower with the same amount of income in my pocket, it's almost like I have more income. And then the reverse is true. Prices go up, same amount of money in my pocket, like I have less income. Right? That's why we don't like inflation. If I tell you that they're proportional, which is the kind of examples I'll use. Okay. The same proportion. Yep. Yep. Okay. Any other questions on this one before we keep moving? Okay. All right. So we'll get out of here. Go back to the slides. kind of set us up for next class, okay? So I might go through some of this a little bit quick, but that's because we already have, once again, a pretty good comparison for this, something we've talked about. It's really simple, okay? So we'll go through some basic definitions first. So I don't honestly exactly know where this comes from. The story I've heard is like the idea of like everything that you buy, even if you like it, might not be a benefit to you. But in economics, when you buy something, we call it that you get a certain amount of utility from it. It brings a certain amount of utility to your life, right? So once again, this is going to sound very similar to when we were talking about total and marginal benefits, right? Here, we're just, instead of the word of benefits, we're just going to use the word utility. So utility is the benefit I receive from consuming a certain good. We're going to have all these different consumption bundles. We kind of already talked about these, like it was just the different combinations of good X and Y I'm buying. So in practice, this might be I'm buying 2 TVs, 1 car, 500 gallons of gas, all the things that you buy, that's your entire consumption bundle. Okay. Now there's going to be some function that's floating around behind the scenes that tells you if you buy a certain amount of this one good, here's what the total utility it's going to bring you, right? So there is this function. We focus a lot more on the functional forms, things like that, if you kind of progress through economics. For now, we're just going to know that if I buy 2 of this, there's some function that would tell me how much the total utility would be. If I buy 4, this function will tell me what the total utility would be, etc. Okay. So with this idea in mind, we're going to focus not just on total utility. So there is this utility function that kind of lives behind the scenes that as you plug in different quantities, it would tell you the total utility. Okay. So you can think about something like this. And I've kind of used these examples before. I think I did like the mowing the lawn and like drinking a beer afterwards or something. But you can do this with any good, right? You can think about, let's say I'm buying cars, right? And just for the sake of this example, let's say I have an infinite amount of money. Like money's I've got income is infinite, right? So if I think about graphing out for every car that I buy, what's my total utility? So once again, if prices don't matter, and there are no prices, I can just go out and pick whatever car I want. Which car am I going to pick first? The car that I like the least? You're going to pick the car that you like the most. Which car you think would bring the most happiness or utility to your life, right? So once again, money's no object. Like, let's say all cars cost the exact same amount, right? So you go out and pick whatever car brings you the highest total utility. Now, once I go to the second car, if I'm measuring total utility, it'll include the total utility of the first car plus whatever I get from the second. So when I go out initially, I chose the car that brought me not the highest total utility, but the highest marginal utility, the greatest amount of additional utility. So just like we were focused on marginal benefits, right? Instead of total benefits, the amount of additional benefit consuming something would bring you. Same idea with utility. So what car do I get second? The car that I liked the second most, or brought me the second amount of highest happiness. So yeah, my total utility is going to be higher, but notice what was the change in my total utility from that second car? It's a little bit smaller. And then the third car I would get, it's the one that I like the third most, right? And not only is it how much I like it. So think about it this way, like with cars, even if I don't have like an unlimited amount of money. Well, the first car is going to bring a lot more additional utility to my life, allowing me to drive places. By the time I get to that third car, it was the car I like the third most, but also I can only drive 1 car at a time, right? So every single additional unit I buy, my margin utility or the change in total utility is going to be getting smaller and smaller. So if I graphed out total utility, you can kind of think about the margin utility would just be the slope, right? So margin utility is declining as we buy more of something. So think about any good as I buy more of it. The marginal utility of the last one that I bought is going to be lower, right? As I buy more and more. Okay. Any questions on this? Like I said, this should look or sound similar to like marginal total benefits. Okay. You got a question? No, you good? Just stretching. Any other questions on this before we keep moving here? Okay. So if I put some actual values to this, it shouldn't be too bad. When we calculate margin utility, it's just the additional amount of happiness or the additional utility that I'm getting divided by the additional number of units I'm buying. So in my example, I was kind of keeping this easy because it was like the change was always one. In practice, we might see people buy like bundles of goods, right? And so like gas, for example, right? You might go and fill up your tank. That's more than just one, right? But that margin utility that it's providing is how much you could drive on those, 10 gallons of gas or whatever it is. So we might have something that looks like this, right? So my animation is turned off or screwed over here, but we'll kind of talk through this. So if I start to buy more of whatever good this is, right? Here I've got quantity jumps of 5. So how was I coming up with this margin utility power? So let's say I wanted to know the margin utility of that 15th unit. How would I find that the margin utility was 6? Well, it's just the change in my total utility, which was 30, divided by a change in the number of units I'm buying, which would be what? 5. So 30 over 5 gives me that margin utility of 6. So we've calculated marginal things in the past, right? So marginal cost was the change in total cost over the change in quantity. Marginal benefit, change in total benefit over change. That's all we're doing here. Now, a lot of times we had quantity changes of 1. Here we might start dealing with some that aren't just 1, so we actually have to focus a little more on that denominator. Any questions on this idea of calculating something that's on the margin? So here we've got, as I buy more of something, notice what was the marginal utility of the first 5 units? Change in total utility was 60. Change in quantity was 5. 60 over 5 was 12. As I continue to buy more and more, what's happening to my marginal utility? It's decreasing. Now my total utility still going up. I'm still, every time I buy, like let's say I went and bought 50 cars. The 50th car still brings me some additional utility. It's just that additional utility is getting really close to 0. I mean, I have 50 cars, I can't even drive a different one every day of the month, right? So it probably just sits there. So when you think about like, it might bring me some minor amount of margin utility, but as I buy more and more of something, that margin utility is declining. Okay. All right. Any questions on that before we keep moving? Okay. Oh. So here I just kind of have a graph of that total utility. I kind of drew it out for you here without numbers, but this is just the idea that my total utility is always going up as I buy more of something, which that slope of my total utility curve would be my margin utility. How much is it changing by? What do I want to have here? We already graphed this. So I want to skip ahead here a little bit, set us up for next class. So in my car example, why don't I buy, even though each car gives me some additional margin utility, why don't I go out and buy 50 cars? Because in reality, they have prices, right? So what am I going to be constrained by? I'm going to be constrained by how much I can buy, depending on what the prices of the goods are and what my income is. So our budget constraint is going to come into play. So we want to try to maximize our happiness. We want to try to maximize utility, but we're facing a budget constraint, right? We can only afford to buy certain things based on our income and prices. We can only afford to buy so much happiness. Right? So when we're thinking about the consumer's decision, yeah.
I would ask, like, how would this utility be in the case when a good has an inelastic supply?
So shouldn't matter for the consumers if the supply is elastic or inelastic, right? This is just how much happiness it would bring them.
Let's say there's only like 1 unit that of that good has never been. So like, how would utility differ than goods?
Kind of depends. Like there's things that there's only one of that I don't give a shit about, right? Like there's like some Pokemon card, there's probably like one of, and I'm like, the margin utility to me is 0, right? Now, I think what you're getting at is what if the margin utility of something is infinite? Hold the thought. I'll come back to it as we go through this next concept. So let's think about when consumers are making this decision, right? What do I buy? I don't just go out and buy the car that gives me the highest margin of utility. So I'll use the example of like, someone on my social media, it's popping up like goofy things like Indiana students always wonder about this house, and it's some IU student point. That mansion, like modern home that's like north, if you drive out, like it's just wild. Like, who the hell lives there, right? Why don't I go out and buy that, even if I have all the money in the, like, let's say I have a lot of money. Well, the margin of utility is really high. Well, I'm probably not going to go out and buy that, even if I had enough money, but I might go out and buy a Polar Pop from Circle K. The margin of utility is much lower for that drink. But what's also really a lot lower? The price. So when you make decisions, what are you really doing? You want to buy whatever brings you the highest amount of additional utility per dollar you're spending. Right? Now, there's also going to come into play how much we can afford our income, but just for the sake of right now, leading us into next class, kind of what are we going to do? Or this, I don't like to use, this is what's the word? Whatever. This phrase, it's like might be like specific to where you grew up or specific to like whatever country you're from. But this idea of like bang for your buck, right? I want to get the most amount of additional utility for every dollar I'm spending. So that's what I'm going to try to make sure I'm doing when I'm making my decision habits. The first thing I'm going to buy, I want to get whatever brings me the highest amount of additional utility per dollar I'm spending. Okay. So once we kind of divide the margin utility by prices, this idea of margin utility per dollar, now when we look across different goods, it's almost like the price of every good is $1. Right? We've kind of equated the prices, and we're just thinking about how much additional utility are we getting per dollar we're spending. So what we end up with in the equilibrium, and I'm just kind of setting this up, we'll kind of show why this is the case a little bit more next class. But consumers will spend to the point where everything they're buying, the margin utility per dollar is going to be the same for every good that they're buying. Now, we haven't talked about where income comes into play yet, but in terms of like what the efficient consumption bundle is, so remember we had that like budget constraint? We're going to end up saying, okay, there's this utility curve that tells us when we buy two different goods, some goods bring me more margin utility than others. Right? So I'm going to try to choose the optimal consumption bundle on that utility curve, where the margin utility per dollar I spent on good X is the exact same as the margin utility per dollar I spent on good Y. So let's go through like a little thought experiment about why this is going to be the case for consumers. Okay. So for now, just believe me that that's going to be true, and we'll kind of walk through why intuition will tell us that it, or we'll kind of back out why that is. So let's say I've got two goods, and I'm telling you that when a consumer is spending optimally, they should be spending where the additional utility they're getting from both goods per dollar they spend is exactly the same. So we'll kind of start out. This is like a logic thing where you try to prove something using the fact that it wasn't true. I forget what logical thing that's called, but that's what we're going to do. So we're going to start out assuming that there's these two goods I can buy, and the margin utility per dollar of good Y is going to be a little bit higher. Okay. So if that's the case, what should I be buying more of? If I'm getting more happiness for every dollar I spend from good Y, what should I do if I can change my consumption habits? Buy more of good Y. So the quantity of Y is going to go up. But remember, our budget constraint, if I buy more of good Y, what inherently do I have to do? Buy less of good X. So what's going to happen as I buy more of good Y? The margin utility of the last unit, so this is the margin utility of the last unit of good Y I buy. If I buy more Y, what's happening to the margin utility of the last unit? We said we have, just like we had diminishing marginal benefits, we have diminishing marginal utility. As I buy less of X, what's happened to the last unit of good X I bought? Its margin utility will be a little bit higher. So I continue to buy more Y, less of X, until eventually these two things are equal. All right. As this decreases and as this, eventually there's a point where they're equal. Now when I'm getting the same margin utility per dollar, do I have an incentive to keep buying more Y? Well, no, because if I do, then what would happen? Well, if I go past that equality point, now the margin utility of good X over the price of good X is higher. So now what should I do? Well, now the margin utility per dollar is higher from good X, so I should buy more X, less Y. As I buy more X, what's happening to the margin utility of the last unit I bought? Going down. Last unit of good Y I bought, it's going up until we get back to this point where they're equal again. So if we ever end up kind of out of this like equilibrium where the margin utility per dollar being spent on both goods is not the same, we know that consumers will change their spending habits, right? And then as they buy more of a good, that changes the margin utility of the last unit they bought until we get back to this point where those things are equal. Okay. So hold on for a second to your question, because this is a good one. This is kind of a wild one. In fact, I was going to use this. I've got a good example for this. So let's say I have the margin utility per dollar. And let's say this is, I don't know. What's a good one? I don't know. We'll do a Tesla. I don't really like Teslas, but whatever. So let's say I'm comparing that to if you had to charge me an amount of money to buy my son, right? What do you think is true about the margin utility my son brings me? To your point, if it was perfectly like, it's not quite really what we would say, but like perfectly inelastic, what is the margin utility? Infinite. So that means in order for these to be equal, what price could you charge me? An infinite price. And I would still, even if you charge me, this gets weird to think about, but infinite minus one, I would still always choose this because it's going to have a higher margin utility. If the numerator is infinite, and it's always going to be an infinite fraction, I'd always choose that thing where I value it at an infinite amount, which is why we see people choose to buy things that what might also have like high margin utilities or infinite margin utilities. If I'm addicted to like heroin, I might not buy any other good except for heroin. I mean, I'm not trying to be glib here. Like that's what you see, right? As soon as those margin utilities start to approach things that are like infinite or like to your point, inelastic, that's where we see consumption bundles. People start buying only that good. And what do heroin users not buy? Deodorant, right? Like all these other food, all these other things. So we can use this very basic kind of model to understand some of these things that we see in real life. All right. So I think that sets up good for next class. Enjoy the weather today. I will see you guys. I'll get those quizzes fixed when I get back to my office, and I'll see you on Thursday.